Yes, sir. Yes, sir. Yes, sir.
Joel, if you are hearing me, on your camera. Ivan, your camera. Niranjan, Aditya Raj, make sure your camera is on. If you are hearing me, please make sure your camera is on. Aditya Raj, if you are hearing me. Ivan, Niranjan, I will not take your name again and again. I will make him to put you in the waiting room. Right. So, I think everybody was there in the last class. Anybody who was not there in the last class from the people who are in the online mode? Anybody who was not there in the last class? All of you were there? Because today's class is going to be the continuation of the last class. If you are not there in the last class and sitting for today's class, nothing you will understand. But you have written your final exam, so you should understand. That's what. So, you wrote the final exam, so you should know all the topics now. Full portion test or full portion? Then you should know this topic, what I am going to teach now. Let us see. So, if I am right, in the last class, we were learning KTG. Last some topics were there which were about to be covered. But the last topic that we have seen in the previous class was regarding specific heat of gas, right? And we found the value of specific heat of monatomic gas, diatomic gas, triatomic linear, triatomic non-linear. Am I right? You remember or not? If I just recall once, how did we do that? We know that we use the formula del Q is equal to del U by del T. That is, we wrote like du by dt, and we found the value of Cv by this. Remember? So, d by dt of if I take monatomic gas for monoatomic. If you are taking monoatomic gas, which is having how much degree of freedom? Monatomic here, degree of freedom 3. So, we wrote the value of this Cv actually. Cv as how much? Cv as I think 3 by 2 kT, isn't it? Actually not kb, kt, t will get differentiated, yes, 3 by 2 kb, isn't it? Or if you want to write in terms of R for 1 mole of gas, it can also be written as 3 by 2 R, obviously for 1 mole of gas. And then we found the value of Cp from the relation Cp minus Cv is equal to R, and we got the value of Cp as 5R by 2. So, by knowing the Cp and Cv, we found the value of gamma. Gamma is equal to Cp by Cv. How much we got the value as? 5 by 3, which is equal to 1.67, isn't it? I hope you remember this. So, the same way we can find the values of Cp and Cv of each gas, and we can find the gamma of each gas. If I do it for other gases, I will make a small table for a reference. That is, if I do for monoatomic, we did now, monoatomic, then diatomic, then triatomic linear, and triatomic non-linear. For each kind of gas, you should know what is the degree of freedom. Tell me, monatomic 3, diatomic, what about triatomic linear, non-linear? What is the value of Cp? 3 by 2 RT, not RT, only R, 3 by 2 R. What about Cv? 5 by 2 R. What about gamma? 5 by 3 is equal to 1.67, isn't it? Yes. So, I will write here as Cv first, then Cp. That is also fine, no? Cv and Cp. Okay. What about diatomic gas? Cv? Yesterday you did, right? Last class you have done, if I am right.
5 by 2R.
5 by 2R. What about Cp? 7 by 2R. So, gamma? How much is that? 1.4 exactly, isn't it? Yes or no? Yes. Triatomic linear? 7 by 2R, 9 by 2R, 9 by 7, 1.28. Is it so? Yes. 1.28. What about this thing? 3R, 4R, 4 by 3. Is it fine? I hope all of you have done this in the last class, because this is the important chart not only for the school examination, it will be very helpful for solving even the competitive examination question. Sai Rakshana, Hemant and Niranjan, don't on your video for 2 minutes, we will put you in waiting room, okay, if you are hearing me. So, the values of Cp, Cv, gamma and degree of freedom I have written on the board. This chart should be in your head, remember that. Today what we are going to do, we are going to do 3 topics today from this chapter, that remaining 3 topics. One is, we are going to find the specific heat, that is Cp, Cv, even the gamma of polyatomic gas, okay. Then we are going to do specific heat of solid, it is there in the syllabus. We can find for solids also, and we have to find for polyatomic gas. And finally, we will go to the last topic of this chapter, mean free path. That is the target for today. And I think last chapter something was remaining from second law of thermodynamics. If time permits, we will go to that topic also. Fine. So, we will proceed ahead. And I think I can go to the next page. Shall I go to the next page? Okay. So, next you give the heading as specific heat of polyatomic gas. Okay. Before I start talking about the value of specific heat for polyatomic gas, you must know how these gases are vibrating or oscillating. So, you know very well that in translatory direction, a particular molecule can have 3 degrees of freedom, maximum I am saying, x, y, z. Same way, if you take rotation, there are 3 kinds of rotation possible in the same, but it will be in a plane. When I am talking about translatory motion, it is one dimensional, either in x, y, z. If I talk about rotation, it can also have 3 degrees of freedom. Please pay attention to what I am saying now. And I told in the previous class to you, each degree of freedom contributes to 1 by 2 kT energy. That is only law of equipartition of energy. Nature says that each degree of freedom should be given how much? 1 by 2 kT of energy. So, in that way only, if it is having 3 degree of freedom, we are giving 3 into 1 by 2 kT, it becomes 3 by 2 kT. If it is having 5 degree of freedom, we are getting 5 into 1 by 2 kT, it becomes 5 by 2 kT, right. So, each degree of freedom is contributing to 1 by 2 kT only in translatory and rotational. Write it down somewhere, it is an important point. The point is, each degree of freedom contributes 1 by 2 kT in translatory and rotational motion. But one thing we are neglecting till now, we have to consider, let us consider it in the case of polyatomic gas. To be very frank, we should have taken that also in diatomic, triatomic and other gases, but we have not considered it till now. What is that? Vibration. A gas, because of heat energy, may start vibrating also. Do you agree with me? A gas molecule may vibrate also. Apart from rotating, apart from moving straightly, if it has restriction of space, it can start even oscillating, or it can start even vibrating, whatever you want to call it, oscillation or vibration, both are almost same. Vibration is quick oscillation. In the case of vibration, that's what I want you to write somewhere. In case of vibrations, or called as quick oscillations, each degree of freedom contributes kT, not 1 by 2 kT, kT. Remember this. So, law of equipartition of energy, last class what I taught you was only for translatory and rotational motion. It was found that in the case of vibrational motion, the contribution of degree of freedom, the energy contribution, is kT, not 1 by 2 kT. So if a particular gas is having F vibrational modes, it will have F into kT, not F into 1 by 2 kT. If a gas has 2 translatory motion, we will put 2 into 1 by 2 kT, right? Like 3 for monatomic, we are putting 3 into 1 by 2 kT. If it is having rotational also, 3 translatory, 2 rotational, we will put 5 into 1 by 2 kT. 3 rotational, 3 translatory, we will put 6 into 1 by 2 kT, am I right? But if we are considering the vibrational modes of, vibrational modes, then each degree of freedom will contribute only, not only, it will contribute kT energy. So, for polyatomic gases, let us consider how many degree of freedom will be there. Obviously, 3 degree of freedom by translatory motion, am I right? 3 degree of freedom due to translatory motion. And we will have 3 degree of freedom due to what? Rotational motion, no doubt.
I have a doubt, I don't understand that part.
Which part?
Rotational, how is it 3 degree of freedom?
See, the rotational motion is what? If there is a gas, it has to rotate like this, isn't it? It can rotate like this, or third direction. One can be like this, one can be like this, and one can be like, see, 3 possibilities are there, right? One in this way. Are you getting? I hope they are able to see, I don't know. Like this. Okay, now let me make it started. One can be like this.
Oh, okay.
Okay, and one can be like this. Understood? There are 3 possible ways of rotation also. So I am writing 3 degree of freedom for rotation. And vibration can be n types. So I am writing F, or you can write even n if you want, F degree of freedom in vibration or quick oscillation. So polyatomic gas, I am assuming 3 degree of freedom in translatory motion, 3 degree of freedom in rotational motion, and F, or you can take n, x, whatever, degree of freedom in vibrational motion. Now I will give time for writing, 2 minutes, I will give time for writing, please pay attention. Now tell me, what will be its total energy? We are doing, no, we are adding all the degree of freedom. So how much it will be that in this case?
6 plus K RKS, right?
Yeah, you have directly gone there.
6 plus F.
3 into kT, 1 by 2 kT, no, translatory.
No, I'm adding both of them.
Yes, we will do one by step by step. 3 into 1 by 2 kT
Plus 3
plus 3 into
1 by 2 K.
once again 1 by 2 kT
And
plus F into kT. Do you agree with me? Totally how much you got? 3 by 2 will become 3. So I will write 3 kT plus F kT. Yeah, I will come to that point. So if I want to find what is CV, which will be d by dt of U, energy, obviously this is all our energy. So it will become equal to 3 kT plus F kT, Tt will be cancelled, so CV will become equal to 3 kBT, T will not come, 3 kB plus FkB. If I consider in form of N and R, I can write Kb is equal to R into N. For one molecule, for 1 mole of gas, I can take N as 1. Yes, so Cv will become equal to, why Kb? R will come, no? 3R plus Fr. Or if you take R common, Cv will become equal to 3 plus F into R. Keep in your mind, Cv is how much? 3 plus F into R. Now, if I want to find the value of Cp, what will be that? You know very well, Cp minus Cv is equal to R. So Cp will become equal to Cv plus R. So 3, I will write like this, 3R plus Fr plus R. 3R plus R will become 4R. So 4 plus F if I take common into R will become my Cp value. Do you agree with me? We got Cp, we got Cv, what will be gamma then? Gamma will become equal to Cp by Cv, which will become equal to 4 plus F by 3 plus R will get cancelled. Gamma is 4 plus F by 3 plus F. Is it clear to you? This is the degree of freedom. That is not degree of freedom, it is the gamma ratio of Cp by Cv for polyatomic gas. So the value of Cp for polyatomic is 4 plus F into R, value of Cv for polyatomic is 3 plus F into R, and value of gamma is 4 plus F by 3 plus F. If it is clear, make note of it fast, and we can include this in that table also. Copy it fast. So your board exams are over, Shweta? Board exams, final exams are over. Officially you have finished your 11th in your school. Board means final 11th. Which school do you belong to, Shadna? What about them? They are going to finish by? When? I missed it. Copied? Fast. Okay. Finish it, then only I'll start the next topic. No? Shall I continue, online people? I hope you are done.
Yes, sir.
Okay. So if I add this, here for polyatomic, degree of freedom will be how much? Not 3, you can say 3 plus F, 6 plus F. And what is CV? 3 plus F. What is CV? 4 plus F. That is CP. What? Yes, obviously R will be there. And what will be gamma? Clear? Coming to the next topic in this chapter, where we are going to learn about the specific heat of solids. In terms of degree of freedom, nothing else. So in solids, molecules will not have chance to go and undergo translatory motion, rotational motion, but still they can undergo vibrational motion, am I right? Because in solids, the molecules are tightly packed. They won't have space to go and reach the other part. That's what happens in the case of solids. We have conduction, we don't have convection or radiation. Radiation is something else. The particles can only vibrate in their position, but they can vibrate like this also. They can vibrate like this also, or they can vibrate like this also, isn't it? This like this, or like this. All three vibrations are possible. So can I say that? Yes, I can say that they will have 3 degrees of freedom in what? In vibration. See, degree of freedom in translatory is different from vibration, isn't it? Degree of freedom in translatory and rotational are same, but degree of freedom in vibration is kT, each degree of freedom. So what will be the energy? Energy imparted.
3
Yes.
kg.
Very good. That will become equal to 3 kT. So what will be the value of CV? 3 kb, or you can write 3R for 1 mole. 1 mole. Per mole if I do, I will get 3. What will be Cp then?
4R.
So what will be gamma then?
4 by 3, 1, which is 1.33.
Okay. Clear? How it is coming to your understanding? Very basic, nothing is there in this. Just 3 degree of freedom, very similar to which gas?
Yes, what's the again, what's the question?
Similar to which gas?
Triatomic bent, sir.
Triatomic? Non-linear. We bent, you are saying, non-linear. Yes, triatomic non-linear. They will also have same 4 by 3. Very basic, just copy it in 2 minutes.
Sir, I have a doubt.
Please tell me.
Sir, are the CP and CV not equal, sir?
Cp and Cv are equal.
Yeah, in case of solid, cause like the change in the volume is not much considered.
Change in volume is not must.
Sir, there will be a very little change in the volume, sir. Like it's negligible.
Okay, so
So if I'm asking you whether CP is
No, no,
equal
no,
to
no.
it, because
if you see, there is not much difference also in Cp and Cv. Are you feeling that? So what you are thinking is partially correct. Don't think they will be having same value, they will be having a little different value.
sir, in school they've given us like equal, sir.
So they have told that gamma is 1 for that. NCERT book is there here? Anybody has NCERT book? Let me check NCERT once, Shivaranjani. There or not there? Here, opening the bag. Thank you. They have written 3R, but they have not talked anything about Cp. Just they have told 3R and then left. Gamma they have not spoken itself. So they have not told the ratio is 1, or they have not told that the ratio will be, it will be same, but they have just considered only one part, it is 3R. They have not talked anything about.
But for NEET and JEE, we will use this book, right?
Yeah, I am not saying it is wrong. They have not spoken about that itself, I am saying. They have just talked about C and they have told it is 3R, and they have not considered the other parameters. Okay? Anyhow, let us go to the last topic of this chapter, which is mean free path. Mean free path. Some topic which can be sometimes very confusing, but very simple this. So try to understand how much you can understand. I will help you if you are having doubt also. Okay. So last class we found the velocity of the gases, right? Approximately diatomic, triatomic we found. Nitrogen I told approximately 516 meter per second, you remember? 516 meter per second, or we found for some numeric, one numerical we got the value as some 400 something meter per second, something like that. So are you realizing that the velocity of these gas molecules is somewhere near to speed of sound? Speed of sound is 330 meter per second, right? It is more, almost equal or more than speed of sound only.
Yes.
It is more than speed of sound only. Do you agree with me?
Yes, sound travels in air, right? Yes, sir. So it should be more than speed of sound.
Why you are saying like that? What is the logic of this?
So because sound travels in
Okay,
air, sir.
okay,
The air particles move and bump into each other, so that we can
okay,
hear each other.
okay.
So anyway, they they are going to be higher operational temperature, right?
I'll come to you. But yes, they are similar. Similar or more or less little bit higher only. Which one? Which one? Gases. Okay. If it is true, if in this room, in one corner, I keep gas cylinder, LPG gas cylinder, okay, and I press the knob, sound will come, no? Sound will come. Then after few seconds, some smell will come. Which will come first, sound or smell? Contradicts, no? Contradicts that velocity of the gas is more than velocity of the sound. Gas had more velocity, or even if it is equal, we should hear the sound and smell at the same time.
So it has to travel through the air, sir.
Okay, then why its velocity is more?
Sir, it's like not directly that topic, sir, but it's like convection and convection.
So,
Sir, due to collision, sir.
due to
Collision of
Collision.
gases. Bombarding.
what happens? We are thinking that if cylinder is kept here and we are standing here, then the gas should reach you like this. We are thinking like that. Sound reaches like that only. Sound will come out, it will form a wave and it will reach you, longitudinal wave. But the gas will not reach like this. Gas will go like this, like this, like this. It will hit and
Gap it will fill the gap.
loudly.
It will fill the gaps. There is gap.
What gaps you are talking about?
The gap between the air molecules is already then zero, right?
Yes, yes, yes. So it will go and first it may go and hit some other molecule also, and slowly it will spread. Sometimes you may not smell also if you are standing very far, because it gets diffused here itself. But somebody standing here, they will smell. If the gas are coming at the rate that it can overcome these barriers and come here, yeah, you may be able to smell it. So the gas having same speed as sound does not behave the same way as the sound behaves. Are you getting? So how it goes? One molecule is there, it will travel like this. One molecule may be here, it will hit it. Then it may change its path. It will go in this direction, it may go in some other direction, isn't it? Based depending upon the collision type. And once again it will go and hit some other molecule, again some other molecule. So a particular gas molecule may have path in a random way, am I right? The distance it travels before hitting another particle is called as free path. As the name says, very simple, free path. Free path means what? Before it goes and hits the other particle, yes, without any hindrance, it has gone and hit. So here I have drawn how many free paths? I am writing it as lambda 1, lambda 2, lambda 3, lambda 4 and lambda 5.
So summate it divided by 3.
Find the mean of all these lambda, it will give you the mean free path. But that is not the solution. Theoretically, I am telling you, you have to find the value. It will be not very long, but yeah, it will be one page of derivation now. We will get something like pi d square into n by v. I will come to that, how it came. But the concept is this only. Concept is mean of all the free paths, that is lambda, if I am taking that as lambda m, mean free path, it will become equal to lambda 1 plus lambda 2 plus lambda 3 plus lambda 4 plus lambda 5 by 5 in this case. If it is n, then lambda n by n. That is the mean free path. But do you think you can sit and measure the value of lambda 1, lambda 2, lambda 3? You cannot. And it is theoretical thing. Theoretically we can say yes, it is the mean of all the free paths. But how do you determine the value of mean free path? I will say the result to you. I think if I remember, the value will come of lambda m as 1 by pi d square into n by v.
D square of the atom.
D is the diameter of the atom. That will be the answer. Or one more thing is there, 1 by root 2 into pi d square into n by v. These are the answers which you are going to derive today. I will tell about both the things why root 2 is coming suddenly. So these are the values of, this is the mean free path if you are not considering the motion of other particles, and this is the mean free path if you are considering the motion of all the particles. I will come to this. But remember, we are going to get this as the answer. NCERT, anybody can verify, I think this is the value. if I am right in my memory. Shivaranjan, you remember? This is the answer.
Yes, sir, we wrote exams.
Oh, you wrote exam. Final exam you wrote?
No, sir, no, sir.
Okay, okay. So this is the answer. That is it's correct you are saying.
Yes, sir.
Yeah, she approved. Fine. We'll move ahead. So let us derive how it comes. Now derivation is little confusing if you are not concentrated. So please pay attention how I am going to derive this. Shall I derive it? Shall I go to that part? You want to write something from here? Okay. Nothing much was there. So now we are going to do derivation. For that, what I am doing, I am considering one atom of gas or molecule of gas, whatever I want to call it, and assuming its diameter is small d, 10, some d, small d, and it is moving with velocity v. Okay. Now tell me, if it is going with a velocity v, which molecules it has a chance of hitting?
Sir, molecules are bigger than.
Molecules will have same size. Particle gas molecules will have same size, right? If it is hydrogen gas, all will be hydrogen, you know.
Everything will be d.
Yeah. So can I say that? See, pay attention to what I am saying. From center, what I am going to do, I am going to draw. What color will be good? Yeah, this will be fine. I am going to draw a circle taking a radius d, same diameter, and if I draw like this, and then I draw a cylinder, can I say that if the center of any gas molecule, if it lies within this volume, it will definitely hit it? Think about it, what I have said. Think about it deeply. If its diameter is d and I take the center of the atom, d as the radius, and draw a circle and draw a volume, that is a cylinder, then I can say that if any other molecule which is going to come like this, why I have drawn this much big, and if its center is lying, I have drawn little wrongly, just I have drawn too much big of this. Let me draw more properly. We have geometrical tools in this. I am not using it much. Shall I try today? Try.
We'll have time, yes.
Thinking, huh? Discipline tool. I don't think subject only it should be. I don't know here. Discipline tool, physics, math only, no? Yeah, see. So, compass shall I take?
Okay. Draw two circles and then. Oh, wow.
Experimenting. Too much big molecule.
Fine, sir.
No.
Let's keep that. Okay.
I can reduce the size, man. This much option is there, then why you should worry? Yeah.
Hold that, yeah.
This also is big only, but okay, fine.
So I could have kept that as a cylinder.
Sorry. Yeah, I'll do it here. Now what I'm doing, I'm drawing a gas molecular atom. How much I have taken, you know? 0.7 and 30. So I'll take 0.14. Sorry, 1.4. And then I'll draw a circle. Okay. Now, where is the tool went there? Yes. I'll take a ruler and then I'll keep it. What is use? I think I should. Help me, man. Yes. size. Okay, I cannot draw a line. Huh? Some option will be there, no? Not that bad. It's only some option. Let me try to at least. Fine, enough. Coming only.
So now it came perfect.
Yeah, perfectly it came. Last time it not came. Now once again.
Is it composite?
No. If you want to draw perfectly, means you should draw a line from here also, no?
Okay.
They are scolding me, online people. You will are enjoying. For them, it is like I am time passing. Why not coming like this?
So I think you have to keep it in the wall.
Okay, leave it, man. I cannot do more than this. Enough. Come out. Oh, close sleeve. Huh. Now you can see. Now it came perfectly, because if I am going to have the same size circle, then its center, if it is lie within this only, it will collide, no?
Yes.
Right? So this is diameter D, and this also is radius D. So I can say that if any molecule is going to come in the volume, which volume? Pi into D square by the distance, whatever length, let it be length L. If any molecule is going to come in this volume, it is definitely going to be heated by this particular gas molecule, right? It is having a velocity V. It is going in this direction with a velocity V. Do you agree with me? If something comes like this, something comes like this, something comes like this, yeah, it is going to hit.
Velocity is greater than equal in second order. This is not point 8.
I'll do that, wait. And one more thing you can see very clearly from here, if the center is lying outside this, no, cylinder, it won't hit. So the molecule's center should lie in this volume for this molecule to hit the coming molecules.
What is in the boundary?
It is graze and go, touch and go, right? One more thing I will say you. Here, to derive this, I will make some assumption. What assumption I will make? I will make assumption like, let us assume all the gas molecules are at rest. Because if we consider their motion also, it will become complex derivation. So, I am assuming everything is in rest and my molecule only is moving. First assumption. Second thing I will tell you, if it would have gone and hit this, what would happen? Its direction also will change in reality. Why volume will change? It will, wherever it goes, it will cover same volume. Are you feeling it? Whichever direction it goes, volume will not change. Direction will change. But see what will happen if I tell you, here I will draw separately that thing and tell you. Suppose it goes and hits some molecule here, okay? And its direction, so I have found this volume. Up to here I found the volume, one volume. And then this molecule moved in this direction. Then I will find the volume like this. Then it moved in this direction. So then I will find the volume like this. Are you getting my point? Like this it will keep on going. I have to find each volume in that direction. But it will be confusing for derivation. So I am assuming that this molecule keeps on hitting and keeps on going straight. Second assumption. Assumption 1 was this. What is the assumption? That all the gas molecules are at rest. Second assumption is the gas molecule in consideration is moving in straight line. You understand the assumptions that I have made? I hope it is clear. Okay? It has a velocity v. If I take the time delta t, that is in time delta t, what is the distance covered? That is only L. Distance covered will become equal to how much? Velocity is v times delta t. V into delta t. Do you agree? So, what is the volume covered by the gas molecule in delta t time?
Similar to Bernoulli, sir. No, not Bernoulli.
Continuity, yeah, up to now only, it will change after this. So, then volume will be equal to pi r square, that is pi d square into height. Height is v delta t. Do you understand how I have done this? Up to here it is clear? Any problem? I don't think. Okay. Now I am assuming, one more assumption I will write 1, 2, it is not assumption, it is a thing which we are taking from the beginning. There are n particles or n molecules per unit volume. Okay. So, small n I am taking as capital N by V, where capital N is the number of molecules and V is the total volume. You understand? So, total number of gas particles I am taking it as N by V for this volume, N by V. Tell me, if the total volume is this much, pi d square V delta t, and total number of molecules is N by V, then how many collisions are possible? Why n collisions, man?
Because the n over a particle.
You have to multiply with V, no?
Oh, okay.
How much volume is there? If volume is big, then there are more collisions possible. If volume is small, the more less collisions possible. So, if I write total number of collisions possible, total collisions possible, that will become equal to pi d square V delta t into N by V. Do you agree? That volume,
Oh, it's different. You're saying it's different.
yes, we will talk about that now. First, you copy up to here. Copy all these things, I will change the board now. Copy up to here, I will change the board. Copied.
Second one, a gas molecule in.
Gas molecule in consideration is moving in straight line. Copied? Online people?
Yes, sir. Yes, sir.
Yeah, make it fast. Make it, I'll wait for a minute. Make it fast. This total collisions possible.
You can take, sir.
Okay. You fast. Bro. Done, Abhinand.
Yes, sir, done, sir.
Can I go to the next page then?
Yes, sir.
Up to here things are fine. Now see what I am writing and tell me whether it is right or not. You think and say, okay. I am writing mean free path, which is actually lambda m, will become equal to total path length, which is L in this case, divided by number of collisions. Do you agree with me?
Yes, sir.
Think and say. Path length is L, right? Path length will obviously be equal to what is the mean free path multiplied by how much time it got collided, isn't it? Now tell me what is the value of path length? V delta t. What is the total number of collisions found out? Pi d square V delta t into n by V gets cancelled. So you get the value of lambda m as 1 by pi d square into n by V. Why I am writing n by V again and again? I can write small n also. You should not forget, small n is number of particles per unit volume, right? Number of particles and number of gas molecules. That will be the number of collisions also, obviously. So capital N here is number of molecules and V is total volume. Please remember this.
Total only covered.
Obviously total volume of which? Covered by a particular gas up to in that mean free path. Are you getting? I gave another formula also in the beginning of today's class, that is root 2 into this. If we consider the motion of other molecules also, then there is a factor 1 by root 2 multiplied with this. So lambda m becomes equal to 1 by root 2 times of pi d square. That is another derivation which is not there in our syllabus also. But is there in NCERT? This formula is given in NCERT? I don't even know about it. This is there in NCERT, I have seen. Is this there in NCERT? Check.
Understand, sir.
Root 2 is given.
Sir, total collision is possible.
I'll talk about it once again. Let me see once book.
The sixth one can
Yeah, they have considered that and that formula also they have given. See, here they have derived that same thing and they have also taken that root 2 assumption. See NCERT how they write. They also write in this derivation we imagine the other molecules to be at rest, but actually all the molecules are moving and the collision rate is determined by average relative velocity of the molecules. So the correct more exact treatment gives 1 by root 2 times. The NCERT book writes 1 by n into pi d square. That small n only is n by v. Okay. This n by v what I have written is, so in beginning I wrote, no, check in the previous page I wrote. See the previous page? I wrote small n is equal to n by v. If you want to replace like this, you can also write lambda m is equal to 1 by n pi d square, or you can write lambda m is equal to 1 by root 2 into n pi d square. You can write like this also. Both are same only. Small n is number of molecules per unit volume and capital N is number of molecules and V is the volume. So when you multiply number of particles per unit volume with volume, you get number of particles. Isn't it? Is it clear? That is about mean free path. Is it clear to everybody? What you are having doubt, Abhinand? What something you are asking?
Sir,
Hmm.
I have a doubt in this, but the total position is possible.
Hmm.
Pi d square into V delta t into n by V.
Where? Here. Hmm.
Yeah, this
Hmm.
one.
Hmm.
So pi d square V delta V is nothing but V, right? What you covered?
This is number of particles per unit volume, not volume covered. This is what is the volume this molecule takes.
Yes, that was next.
And here V is number of particles in unit volume. If V small capital V will change, number of molecules will increase.
Number of molecules is
Obviously, this is number of particles per unit volume. In 1 meter cube, 1000 particles can be there. In 2 meter cube, 10,000 more particles can be there accordingly. So this is number of particles per unit volume, and this is the volume
entire one covered by the
this particle alone.
this one.
Yes, this volume.
It goes. The
Yeah.
summation of all the volumes.
Summation of all the volume. Okay. So if you have written this, then KTG also is literally finished. Are you understanding? So, numericals are not, I mean, they are from this topic much. We will discuss numericals in the tomorrow's class. So you can make me out of a live now. Should I? Live stop kar do.